Law of sines. Let's talk about an oblique triangle first. If none of the angles of a triangle is a right angle, the triangle is called oblique. All angles are acute is one type of oblique triangle, and the other is when two acute angles and one obtuse angle. An acute angle is one that is less than 90 degrees. An obtuse angle is one that is greater than 90 degrees. To solve an oblique triangle means to find the lengths of its sides and the measurement of its angles. There are four types of obtuse triangles to solve. One side and two angles are known, SAA or ASA, side angle angle or angle side angle. Two sides and the angle opposite one of them are known, side side angle. Two sides and the included angle are known, side angle side. Three sides are known, side side side. The first two we use the law of sines. The second two we will use the law of cosines in the next video. Here are two examples of one side and two angles that are known. If we continue, we could say we have alpha, side B, and gamma, or we could say that we have alpha, side C, and beta. Two sides and the opposite one of them are known, side side angle. So let's look at a couple more examples. We could have side A, angle alpha, and side C. Or we could have side B, angle gamma, and side C. Two sides and the included angle are known, side angle side. Another example would be side A, angle beta, and side C, or side B, angle gamma, and side A. Three sides are known, and this is pretty straightforward. We would just know all of the sides. Calculator note, finding an angle. Let's say we have the sine of beta equals 10 times the sine of 45 over 8. The Greek letters tell us we're looking for an angle. So what I did to figure out this one is first, I put the top in and then divided by the denominator. If you'd like, you could put the whole thing at one time, but I find that I always miss a parenthesis, so I like to split it up. Now we know that the sine of beta is approximately 0.88. To find beta, we use the sine inverse. To find the sine inverse on your calculator, you would do second, sine, and then the decimal. So it turns out that beta is 61.6 degrees. The law of sines. For a triangle with sides A, B, C, and opposite angles alpha, beta, gamma, respectively, we would have this formula. On the triangle, it would look like this. Here is our angle alpha, and opposite is our side A. So we would have the sine of alpha over A. To continue, we have the angle beta, and opposite is the side B. And then finally, we would have the angle gamma and the side C. Remember that when you add the angles of a triangle up, they should equal 180 degrees. Solve the triangle when alpha equals 30 degrees, beta equals 70, and A equals 5. The first thing you always want to do is fill in the triangle. So we know that alpha equals 30 degrees. We also know that beta equals 70 degrees, and that A equals 5. The first and easiest thing to find would be gamma. Gamma equals 180 minus 30 degrees minus 70 degrees, which gives us 80 degrees. So gamma is 80 degrees. Next, we need to find one of the sides. I decided to find side C first. So here's our formula. We'll have the sine of 80 over C. Remember, it's opposite the degree, equals the sine of 30 over 5. The reason I chose the sine of 30 over 5 is that we know the angle and the side. We're going to cross multiply. So what that means is we're taking 5 times the sine of 80 and C times the sine of 30. To do that, we want to get C by itself. So what I did is just divided by the sine of 30 on both sides. When I solve this, I get approximately 9.8. From the calculator picture, you can see that I did the numerator first, then divided by the denominator. That gives us C equal 9.8. The last one to find is side B. Once again, I'm going to use the law of sines. I know that beta is 70 degrees, so I have the sine of 70 over B equals the sine of 30 over 5. Remember, this is alpha, and this is side A. When we do that, we cross multiply, so I have 5 times the sine of 70 equals B times the sine of 30. I divide both sides by the sine of 30 to get B by itself, and it turns out that side B is approximately 9.4. Once again, here's what my calculator shows. I did the numerator and then divided by the denominator. And now fill in the last part. B equals 9.4. Solve the triangle A equals 8, B equals 10, and alpha equals 45. First, we always put in what we know. We know that B is 10, A is 8, and angle alpha is 45 degrees. Let's find beta first. So to find the angle beta, we're going to use the law of sines. And just like on our last example, we're going to cross multiply. We want to get the sine of beta by itself, so we need to divide by 8 on both sides. And then we figure out the sine of beta equals 10 times the sine of 45 over 8, which turns out to be the same thing as 0.88. Then we're going to use the sine inverse to actually figure out the angle beta, and we get it to be 61.6 degrees. You can see here, I figured out this one, and then the bottom is the angle. We have something interesting with this triangle also. If we drew another line from the top, we would get an isosceles triangle. Now you're right, these two sides don't look the same, but they're supposed to be the same. And so we figured out that beta is 61.6 degrees. Let me show you the two triangles that this one will split into. We have the small one, the original one that we started with, and then we have this larger one. And this angle here is the same as this angle here. Alpha is still 45 degrees. Side B is still 10. Side A is still 8. Now this side is the same as this side. In an isosceles triangle, this angle is the same as this angle. To figure that out, what we do is we just take 180 minus 61.6 equals 118.4. The reason is this is a line, and a line is 180 degrees. So if this angle is 61.6 degrees, this side has to be 118.4 degrees. So this angle turns out to be 118.4 degrees. Now I realize that this triangle doesn't quite look right because this looks like an acute angle when it's really supposed to be obtuse. But we get the idea here. One thing to remember is that you'll have two triangle solutions only when two sides are not between the angle. So if we look back up here, we had this angle, this side, and this side. The sides are not between the angle. So let's figure out triangle 1, and that's the little guy. So we know that beta is 62.1 degrees, and I'm going to call it beta prime for now. This is gamma prime. We also know that alpha is 45 degrees, side B is 10, side A is 8. The easiest one to figure out would be angle gamma, which once again I just take 180 minus 45 minus 62.1, which gives us 72.9 degrees. Now the only thing we have left that we haven't figured out is C, side C. So to do that, we're going to use the law of sines. Exactly what we've done before. We've cross multiplied. Here's what the calculator shows, and we get side C to be approximately 10.81. So this is the answer for our first triangle. This is our second triangle. We know that alpha is 45 degrees, beta is 118.4 degrees, side B is 10, side A is 8. Just like the last one, the easiest part to find is gamma, angle gamma, and we figure out that to be 16.6 degrees, which leaves us C to find, side C. Once again, we're going to use the law of sines. We're going to get C by itself. And as you can see from the calculator, there's the top divided by the denominator. We get approximately 3.2. So C is approximately 3.2. And then, of course, here's the answer for that entire triangle. Solve the triangle B equals 3, C equals 5, and beta equals 50 degrees. I filled in everything we know and decided we're going to solve for gamma. We're going to use the law of sines, and it turns out the sine of gamma equals 5 times the sine of 50 over 3. So the sine of gamma is approximately 1.3. This is interesting because the sine cannot be over 1. It always has to be less than 1. So it turns out that there's no triangle with the given measurements. Here's a problem for you to solve. Press pause, solve the triangle, and then play to see the solutions. And here's the solutions for the triangle. Once again, I would like you to try to solve this triangle. Press pause, solve the triangle, and then play to see the solutions. Thank you, and be sure to watch the next video, Law of Cosines.